All right, so this lesson is primarily going to cover the distributive property and combining like terms. So let's start with combining like terms. So in order to combine like terms, what you're combining has to have the same variable factors. If they have the same variable factors, then we call those like terms. So let's see what I mean by that. So 7a and negative 3a are called terms, and these terms could be added or subtracted together. So first, before we can determine if we can add or subtract them together, we have to determine, do they have the same variable factors? So the variable factors for both of these are a. So they both have the same variable factors of a. So are these like terms? Yes, because their variable factors are the same. So if they have the same variable factors, then I could add or subtract these together. So let's see how that would work. Let's say we were going to add these together. So 7a plus negative 3a, that would be positive 4a. So what you see is that I kept the variable factor and all I did was combine the coefficients. So the numbers in front of a variable are called coefficients. So 7a plus negative 3a is equivalent to 4a. All right, let's look at this next set of terms. So I have 4x squared and 12x squared. Well, the variable factors for both of these are x squared. So the answer is yes, they are like terms because they have the same variable factors. And again, let's say we wanted to add these together. You would keep the variable factors, so x squared, and then I would just combine the coefficients. So 4 plus 12 is 16x squared. All right, let's look at the next one. The first term has variable factors of a times b, or ab. The second one, the variable factor, is just a. So these are not like terms. They have to have the exact same variable factors. So I would not be able to add or subtract these. The next two terms, the first one is xy squared, and the second one is x squared y. Those are not the same, so the answer is no, those are not like terms, and I could not combine them. So it has to be the same variable, and if there's exponents, it has to have the same exponents. So if you go back to this example here, if one of these was x squared and one of them was x, then they would not have the same variable factors, and I could not combine them together. So when you're adding and subtracting terms, you can only add and subtract like terms. Now we're going to find out later, you can multiply and divide unlike terms. So 6ab and negative 2a, I could multiply together. All right, so let's look at some examples of this. So both of these have the same variable factors of x squared, so these are like terms. So I can add those together. So 8x squared plus 2x squared is 10x squared. All right, now here's one with some different variables involved. Now when you have this occurrence where you have different variables, you want to combine the variables first, and you want to start with whichever variable comes first in the alphabet. So here I have x and I have y. So I want to combine the x's together first. So here's a 5x, and I want to combine this with the 3x. Well, whatever symbol is in front of that 3x belongs to it. So that symbol right there, that minus sign, belongs to the 3x, and it tells me how to combine it with the 5x. So 5x minus 3x would give me 2x. All right, now I go to the y. Again, this plus sign belongs to the 6y, and there are no other y's that I can combine it with, so I just bring it down. It doesn't have any like terms. And then last, you do numbers. Again, this symbol belongs to the 3, and the plus sign belongs to the 4. So if I was to pull those two out to the side here, this is what I would have. So that minus sign, I'm going to treat that as like a negative 3 because that symbol belongs with the 3. So what I'm doing here is negative 3 plus 4. Again, the plus sign came with the 4. Those are different signs, so you would subtract them. That would give you 1, and the bigger number is positive, so it's positive 1. So since it's positive 1, I'm going to write plus 1. If this came out to a negative 1, then I would write minus 1. So the symbol that's in front of this 1 is a positive sign, and we don't write that with positive numbers, but it is there, and that's why it ends up here. So what I just wrote, 2x plus 6y plus 1, is equivalent to the expression that we started with. It's just written in a simplified form by combining like terms. All right, and then this last example here, these both have the same variable factors of mn to the fourth. So I can combine negative 7. Again, that symbol belongs with the 7, and this symbol belongs with the 5. So what I'm looking at is negative 7 minus 5. Remember, any subtraction problem we can change into an addition problem. So you can do change, change, or you can just do what I call it is add the opposite. But you change the minus sign to a plus, and then you take the opposite of the number that comes after it. So what I have is negative 7 plus negative 5. Those have the same sign, so I add them. The larger number is negative. So this would simplify to negative 12 mn to the fourth. All right. Now, let's look at the distributive property. What you see here are two examples of the distributive property using variables. And when you use the distributive property, what you're going to see is a number or variable next to parentheses. And inside the parentheses, there's going to be two or more terms being added or subtracted together. So a number or variable next to parentheses means multiply. And the reason this is called the distributive property is I'm going to distribute what's outside the parentheses to everything inside the parentheses using multiplication. And again, the reason I'm using multiplication is because this a next to the parentheses means multiply. So all I'm going to do is multiply a times b and a times c and keep this plus sign here. So this is going to simplify to ab plus ac, because a times b is just ab. Remember, a variable next to a variable means multiply. And so this would be your final answer. All right, so what if this a is on the right side of the parentheses instead? Well, if you want, you can move it over to the left side, because the commutative property of multiplication says that you can change the order of multiplication. 2 times 5 is the same thing as 5 times 2. So it's your choice. If you would prefer to have this on the left side, then move it over there and do what we just did up top. Or you can keep it on the right side and just distribute from here. But either way, you're going to end up with the same answer of a times b plus a times c. There you go. So let's look at some examples of this. So the one, I've got 3 times x and 3 times 8. So 3 times x is just 3x. Carry over the plus sign, and 3 times 8 is 24. Now, I can't do any more. I can't add these together because these aren't like terms. This has a variable factor of x. This one does not. All right, the negative 7. Again, if you prefer to move it over to the left side, you're welcome to do that. A lot of students like to do that, so I'll rewrite it with the negative 7 over here and distribute the negative 7 in there. So negative 7 times positive 5b would be negative 35b. Now, when I bring this negative sign in with this minus sign, this is going to be really important. Whenever these two symbols come in together, it always creates a plus or a positive. You can think of it either way. Basically, what you're thinking of is a negative times a negative is a positive. So when I bring this negative in with this minus sign, it's going to make positive 28. And we will be using a lot of that in algebra. So that keeps showing up. All right, what about if there's fractions? Okay, it's not a problem. 12 times 3 is 36. I'll bring down the minus sign. 12 times 1/6. So if I want to do 12 times 1/6, I would do 12 over 1 times 1 over 6. There's a t here, right? I'll put the t. And remember, when you multiply fractions, you can simplify the diagonals. So these have a common factor of 6, so that would be 1 and 2. And then when I multiply straight across, I would get 2 over 1 times t. That's a t, I promise. Rewriting, that's terrible. 2 over 1 times t. And 2 over 1 is the same thing as just 2. So this would be 2t. Another way of thinking about this is when you multiply 12 times 1/6, that's the same thing as just dividing 12 by 6. So 12 divided by 6 is 2. All right, again, the negative y is on the right side. If you prefer to move it to the left side, you're welcome to do that. Y minus 1. So I'm going to distribute this in here. Oops, sorry, I lost my pointer for a second. Distribute this in here. Negative y times positive 2y. So we haven't seen this before. Y times y is equal to y to the second power. Remember, a power is saying multiply the base times itself this many times. So y to the second power is the same thing as y times y. If you had x times x, that would be x to the second power. All right, so a negative times a positive is a negative, so this becomes negative 2y squared. And again, here we go. We've got a negative coming in with a minus. Told you up here, when that happens, make it plus. And you don't need to write 1y, you can just write y. 1y and y are the same thing. All right, I kind of ran out of room here. Change colors. When you have a negative sign out here, there's two ways you can think about this. The way I like to think about it is I just distribute a negative sign into here. The other way you can think about it is you can think about there being a 1 here, and you're multiplying these by negative 1. So I just think, okay, bring the negative sign into the a, so that makes negative a. Now up here we said if a negative comes in with a negative, or a negative comes in with a minus, you can think of it either way, makes a plus. The same is true if these two symbols come into each other. I shouldn't say the same, because it's really the opposite. If the two symbols coming in are different signs, it makes a minus sign. So this negative coming in with this plus is going to make minus 5. And that's your answer. So I brought the negative sign into the A, I brought the negative sign into the 5, and the plus and the negative make a minus there. All right, negative coming into negative x, negative and a negative make a positive. So that's positive x. And then this negative coming in with the minus makes that a plus 31. All right. You might want to back this up and watch this again. There's a lot of information in this, and all of it is very important. All right, the last piece I want to show you is rewriting fraction expressions. And this becomes important later on in algebra. So basically, all we're going to do is tear this apart. We're going to break it into two pieces. 7x plus 2 divided by 5 can be written as 7x over 5 plus 2 over 5. Just think about it. If I was to add these together, they got a common denominator, so you would keep the denominator, and then you would just add the numerators together, and 7x plus 2 is 7x plus 2. So these two expressions are equivalent. And later on in algebra, you'll find out why this is sometimes necessary to do this. Now, you should check to see if the fractions can be simplified. In this case, they can't. You'll notice this fraction is improper. 7 is greater than 5. But in algebra, that's okay. We're okay with improper fractions, so you can leave it like that. All right, so let's do the same thing with this one. Break it apart. Put the 11 over 6 plus 3x over 6. 11 over 6 is improper. That's okay. 3 over 6 can be simplified because they have a common factor of 3 to 1 and 2. So I'm going to rewrite this as 11/6 plus x over 2. I didn't write the 1 because 1x is the same thing as x. Another way that you could write this, a lot of times you'll see x over 2 written as 1/2 times x. So I just want to make sure that you're aware of that. So 1/2 times x is the same thing as x over 2. All right, so if there's any pieces of that you need to watch again, just back it up and watch it again. There's a lot of information in there. Hopefully I explained it well. Until next time.